This is my video 2 for Computer Science 345, Computer Networks, focusing on chapters 7 through 12. Chapter 7, we talked about network architecture, learn about types of switches, security management, hypervisors, and cloud architecture models. So types of switches, there's unmanaged switches, which are just simple plug-and-play devices. They have no IP addresses, and they're usually used in small or home networks and have limited features. Managed switches are configurable through the command line or through web interface. They allow monitoring, grouping, and better security for large networks. Layer 3 switches can route traffic like routers, and they use network layer data. Layer 4 and up switches, they're also called content or application switches, and they can perform other functions such as advanced filtering or statistics. Switch port security protects the network by controlling which devices can connect to a switch. Attackers can use MAC flooding to overload the switch and gain access to network data. Administrators can prevent this through disabling unused ports. They can use commands like switch port security to limit how many devices can connect to each port, and this creates an important layer to protection. So switch port management, switches control how data moves between devices in LAN. Multiple switches can be used for in large networks for redundancy, so that if one path fails, another can take over. Redundant paths can cause network loops, and that can lead to broadcast storms that slow down or crash the network. Storm control prevents flooding by limiting broadcast and multicast traffic. And then the spanning tree protocol, or SDP, fixes loops by declaring a root bridge and blocking extra paths. Hypervisors, so we talk about virtualization, which allows multiple virtual machines to run on one physical computer. A hypervisor is software that creates and manages virtual machines and shares hardware like the CPU, memory, and storage. Type 1 is bare metal, and it installs directly on hardware, and it's fast and secure. Type 2 is hosted, which runs inside an existing operating system, and it's easier to use, but it's slower. Each virtual machine has its own virtual network adapter, or VNIC, that connects to a virtual switch or a vSwitch managed by the hypervisor. The main connection types are bridged mode, NAT mode, and host-only mode. Cloud architecture models. So we talk about cloud computing, which is the provisioning of services, data storage, application, and other resources over a network. The key characteristics that we covered were that it's a metered service. You can pull the resources together. It's scalable and elastic, so that larger companies can use it, or even smaller companies, and you can have consistent access. Then the different models that we talked about are infrastructure as a service, platform as a service, on-premises, software as a service, and anything as a service. Infrastructure is you just use the hardware it's hosted virtually to the client. Platform, it includes the OS and the hardware. On-premises is all hardware and software are located and managed within the client's locations. Software as a service just provides the software applications to the client, and anything as a servant is like a blank slate, so the cloud will be built specifically for the client based on their demands. Chapter 8, we talked about network segmentation, learned about operational technology, subnetting, types of VLANs, SVIs, and cloud networking. So network segmentation is creating multiple smaller networks where one network's traffic is separated from the others, decreasing the broadcast domain. The broadcast domain it consists of all the nodes of broadcast message can reach. Operational technology is the hardware or software that interacts directly with physical infrastructure or devices. And industrial IoT, which is industrial systems connected to the internet for decentralized control and data collection. Network zones in operational technology. So untrusted zones are like the internet itself. So it's anything that's outside of an organization's control. Traffic from this zone is heavily filtered and even blocked in some cases. Trusted zone is the internal network that the employees can use. Devices in this zone do not have direct access to the internet except through a proxy. And then the screen subnet, or the DMZ, it acts as a buffer between the untrusted zone and the trusted zone. And devices in the screen subnet, usually have access to the internet. Subnetting is dividing a large network into smaller, manageable networks. Each subnet has its own IP range and broadcast domain. Routers are used to separate broadcast traffic and connect subnets. Benefits of subnetting is it reduces network congestion, makes IP management easier, and it improves troubleshooting and scalability. So VLANs, or virtual local area networks, they logically divide a physical network into multiple virtual networks, and each VLAN behaves as a separate broadcast domain. So they're configured on managed switches, and then they have their VLAN trunk links that allow multiple VLANs to share one physical connection between the switches. On layer 3 switches, you can create a virtual interface for each VLAN. Switch virtual interfaces, or SVIs, they provide inter VLAN routing, so you can talk like VLAN to VLAN, and they also allow switch to route traffic without using an external router. Types of VLANs: there's default, which is pre-configured, includes all ports until it's reassigned. Data or user VLAN carries regular user traffic such as web and email. Management VLAN is a switch used for switch configuration and remote access. And voice VLAN supports voice over IP, and it prioritizes low latency and quality of service. Virtual private cloud, it's customer managed, software defined portion of a larger cloud-based network. Private subnet is it hosts resources that should not be accessible from the internet. A public subnet hosts resources that should be accessible from the internet. And then edge computing adds the ability to run computer resources in a physical location closer to the user. Chapter 9, we talked about wide area networking. So we learned about characteristics, routing protocols, types of routers, proxy servers, and firewalls. So some of the characteristics: WANs use networking devices that connect to networks spread over a wide geographical area. Wide area networks and local area networks may differ at layers 1 and 2 of the OSI model, but many of the protocols that they use are the same for layers 3 and above. So routing protocols and types of routers. Routers can connect dissimilar networks, so they can connect LANs and WANs together. They can interpret layer 3 and layer 4 addressing. They can determine the best path for data to follow from point A to point B, and it can reroute traffic if the path of first choice is down, but another path is available. Types of routers: there's core routers, or interior routers, that direct data between networks within the same autonomous system. An autonomous system is just a group of networks operated by the same organization. Edge routers, or border routers, connect an autonomous system with the outside network, and then exterior routers are anything that's outside of the organization's autonomous system. A proxy server acts as an intermediary between the external and internal networks, and it screens all incoming and outgoing traffic. Firewalls are specialized devices or software that selectively filter or block traffic between networks, which it might be placed internally where it resides between interconnected private networks, but it's usually placed on the edge of a private network, and it monitors the connection between a private network and a public network, such as the internet. Chapter 10, we talked about risk management, and we basically talked about the types of risk and then risk assessment. So types of risk, we talked about data breaches, which are unauthorized use or access or use of sensitive data. Hackers, or anyone that's skilled in computer systems. There's 3 kinds. White hat, or an ethical hacker, is authorized to find vulnerabilities, and it's for protection. Black hat, break-ins break security for damage, theft, or personal gain. And then gray hat is kind of in the middle, where they violate laws or boundaries to reveal these flaws, but they don't have a malicious intent. Vulnerability is a system weakness that could allow compromise. Exploit is the act of taking advantage of the weakness. Threat is anything that can cause harm. Risk is the likelihood that a vulnerability will be exploited. And zero-day exploit are attacks on software flaw that before the patch exists for it. Other types of risks, so social engineering is manipulating people to gain access to information. Some types are phishing, where you get messages where they try to steal your credentials. Baiting, where you leave infected files or USB drives for someone to actually use. Quid pro quo is offering free gifts or help in exchange for information. Dumpster diving is retrieving sensitive information from discarded materials. Physical and insider threats. So tailgating is if an unauthorized person slips behind an authorized user. Piggybacking is if the unauthorized person actually deceives an authorized user into letting them in. And shoulder surfing is just observing someone entering credentials or accessing data. So risk assessment, security risk assessment evaluates network threats and vulnerabilities. Business risk assessment evaluates how potential threats affect operations. Vendor or third-party risk assessments evaluate the security and compliance of suppliers and partners. Posture assessment, full network review to find potential weaknesses. And then a security audit or an IT audit is a formal evaluation by a qualified accredited company. Chapter 11, we learned about access controls, we learned about security policies, AAA, passwords, all that. So security policies, they focus on what users are allowed to do and provides expectations of how they can keep a network secure. So there's bring your own device, all these bring your own policies. So bring your own device, you can bring your own smartphones, laptops, technology, whatever you want. Bring your own application, you have to supply your own choice of software for a device. Bring your own cloud, you can choose your own choose your own cloud application or storage. Bring your own technology is that's like the generic reference to all these BYO options. And then choose your own device. You can choose from a limited number, so the company will provide like these are the kinds of devices that you can use, and you'll have to pick from those. So authentication, authorization, and accounting is AAA. Authentication is the process of verifying a user or system's credentials to grant access to secured resources on a network. Authorization determines what an entity can and cannot do on a network once they have access. And then accounting keeps record of everything that you did on the network. Network access control is controlling access to a network and its resources. Identity and access management is a framework that manages all kinds of access to system, networks, databases, storage. Chapter 12, we talked about performance and recovery, talked about network management, best ways to capture a network, bandwidth management, and incident response. So network management refers to the assessment, monitoring, and maintenance of all aspects of a network, ways to capture network traffic, protocol analyzer, network monitor, inline monitor, port mirroring, wireless monitoring, and logs and reporting. Bandwidth management, so flow control, it configures interfaces and protocols to balance permitted traffic volume with the device capability of handling traffic. Congestion control adjusts the way network devices respond to indications of network performance issues caused by traffic congestion, so they don't make the problem worse. And then quality of service prioritizes some traffic over others, so you get the most important traffic, even if the network's congested. So incident response, we talked, there's 6 steps. So preparation is to plan ahead and set procedures. Step 2 is to detection and identification, so you notice and confirm the incident. Step 3, containment, so you isolate the affected systems. Step 4 is remediation, so you fix the root cause. Step 5 is recovery, so you restore systems and operations, and then step 6 is to review, where you learn from it and improve.